Okay. So this final is going to be cumulative, which means it's going to have stuff from everything we've done this semester. Chapter 1 was, of course, the definition stuff. Chapter 2, we hit our first equations. You got the most basic one ever. I'm not going to make you, I told you this, I'm not going to make you do the charts to figure out the variance like we did on the first test, and you supposedly did in the first homework. I told you I wouldn't do that, so you don't have to write those summation of x minus mu squared over n, square root of that. You don't have to write those down. And if they're on your formula sheet, great. Let me think. Then we get to chapter 3. Anything else from chapter 2? I don't remember anything else. Chapter 3, of course, is probability. So you got these guys. Of course, you see OR is basically add, and is basically multiply. I say basically because there's these adjustments that we do in certain situations. Okay. Maybe. Then we get to chapter 4, which is the XP of X business and the binomial stuff. So that's all chapter 4. And again, if you want to see how this is the variance, if you want to write this as a big square root, you can say, okay, can I do this and not freak anybody out? If you want to write it like that, you can, just to remind yourself, right? Either way, or both ways. Do the same equation, I don't care. Just remember, you got to take a square root to get the standard deviation of that. Then chapter 5 was uniform distributions, the idea of continuous distributions in general. No formulas there to worry about, or that I'll let you have. Chapter 6 was normal distribution stuff, which we should be definitely used to this kind of stuff. So you got this guy, you got this weird little dude. I'm going to write that again in a minute, and you'll see why. Oh, and this is also, I always forget about this poor little dude, the little backwards dude. It's like the best Z ever made in my whole life. It's a very low bar. So. Okay. Then this is chapter 6 and 7. Right, because 7 was all about the central limit theorem. That's when we changed the standard deviation. I like it. Then we borrowed this idea and created the confidence interval formulas. This is chapter 8. Then, of course, we get to our favorite chapter ever, hypothesis tests. Some of you guys still don't believe me when I say you have to do this. You kind of left the S alone, but again, S and sigma are for individual data points. If I have a group of data points, I must change the standard deviation to become 1 for a group of size n. So I don't give a shit which standard deviation you know. It's the one for individuals. You have to change it. Let's see. Oh. And then you got this guy. I think that's it for that. And then you got, let's see, for linear regression, there's no formulas. There's just another procedure. And then you got the very last dude, the chi-square. So that's the semester. I love calling it a semester, even though it's less than 4 weeks. The semester in a nutshell up there. Holy shit.
What about the one for the T-star for two meetings?
Same as before. If you want to write that down on your formula sheet for the T-star for the chapter 10, do it. If you don't want to, don't do it. So right now I'm open to suggestions for more stuff. Anybody want to put more stuff on there? The way I ask that question, you're lying if you don't say something, but obviously something I would find reasonable. That definitely cuts it down. Okay, no? Okay, that's it. I like it. So, now it's wide open to whatever you guys want to talk about from the entire frickin' 3.5 weeks of statistics. Yes?
Is your final at 9 tomorrow?
Say again?
Is the final at 9 tomorrow? 9 o'clock?
Yeah, same time. Yeah, same place. We'll probably start with a little bit of review and then get into it. Yes?
So we can ask questions about this practice then?
Oh, hell yeah.
Okay. So for number 2, use this section number 2.
Number 2? Yeah.
This is 2 pieces of paper are selected without replacement.
Yes.
Line the P2 off.
Probably red then green.
Uh-huh.
Okay. So without replacement. So everybody got? Oh.
No.
So we're talking about that number 2 problem on the praxis final?
Are you going to give us the solutions?
Yes.
Sorry.
No, it won't. It's just not enough. So that number 2 problem, the final, praxis final, it's got the 3 pieces of red paper, 3 pieces of green paper in a hat. I'm going to pick 2 without replacement. So it's probably get a red, is red then green, right? Let's probably reach in there and get a red piece of paper. 3 out of 6. Is that cool? I eat it. Let's probably now reach in there and get a green piece of paper. How many green pieces of paper are still in there? Out of how many pieces of paper? There. So it's 3 out of 6 times 3 out of 5. Right? And means multiply. Yes?
So for number 9, you don't give the amount of female students in the sample, so.
Oh, okay. You'll see on the answer key, I actually reworded that problem. It used to be a chapter 10 problem. but I made that extra credit. So all female students at a mean of 290.6, that's the population. So our claim is that the mean for men is the same as the mean for women, right? So our claim is mu equals 290.6. And the sample of men is what I then use in step 4 to make a T-star and whatever. Is that cool? So it's not two samples, it's one sample and I'm comparing it to another population.
So it is a chapter 10.
No, it's not two samples. Chapter 10 is all about two samples. Chapter 9 is all about, I took one sample, only took one sample, and I'm comparing that to some known value or some expected value or something. Yeah. And actually, we're going to do that one together because as I think about it, I never put that on there. So let's do number 9 on the practice final. How are we doing on these? We're still, okay. I'll have a snack break. Read through number 9 on the practice final if you want to. You don't have to do this. Try to do the first step. Write down what the claim is and the hypotheses. Real quick, make sure the machine didn't pick back up again. All right. So everybody got all these formulas? All the formulae? So what's the claim that's being made? We kind of gave it away a minute ago, but yeah, mu equals 290.6. Does everybody see that? What the hell is the 300.4 number? What's that? Sample mean for the men. So that's never going to show up in the claim. Why the hell would I make a claim about something I can see? Right? I'm going to make a claim about something I can't see. I can't see the entire population of men. But I'm claiming that their mean is the same as the women's mean. So, of course, where does that go? I always wish that my dean would walk in when we're doing one of these problems. And then what's H1 going to be? Not equal to. The opposite of equal to, not equal to. So how many tail tests is it going to be? Yeah, this is the only time it'll be a 2-tailed test. I don't care which direction it ends up. By the way, let me see. I don't think I gave, on the actual final, I'm not going to just leave it. I'm going to show you the 5 steps like I did on the tests. I think I just did this so I didn't have to use a third piece of paper. Where am I? Oh, so what can I use, Z or T? Or nothing? Zort. Yeah, why do I have to use a t-score? Why can't I do anything? Why can't I do something? Yeah, n is 37 greater than 30. Check. Now I know which one do I have to use while I only am given S. You can say only know S, or you can say sigma unknown. That's the key thing, is which standard deviation do we know? So then I have to use a t-score, because that's why they were invented. They were invented from when I don't know the real standard deviation. If you think I've said that many times, I have. All right, and then what's my rejection region? Do I give us an alpha? Oh, good. Alpha is 0.01. It's a two-tail test. I'm using t-scores, so what's my degrees of freedom? I think I heard it, 36, or somebody. Okay. So if you try to look it up on the t-score chart, what do you end up getting? The t-score somewhere, I don't know. What do you get? 2.7. 19? Is that what you guys got? Anybody else? Huh? Oh, there it is. Yeah. Two-tail, what was it, 0.01? Yeah, I like it. Kick ass. So if T star is
Greater, no,
less than negative 2719 or greater than positive 2719. All right, now real quick. I've given you several, like how to interpret the conclusion, but you have to base it on what just, believe it or not, some of you guys are gonna, at least inside your head, laugh at this, but on what makes sense. You stop making sense on the fourth day, Jeff. Oh, well, shit. It all makes so much sense. It's almost scary, but this guy thinks it's in here. Right? So if we do get something less than that or greater than that, what can we say about this guy? We can reject it. We're like, you're insane. Look what we just did. Right? So it makes sense. What we reach, if we do get in there, that's why it's called a rejection region. Get down here, Jeff. Reject the hoe, which I can also say support die.
I found a phone in the girls' bathroom, and I noticed someone just went from in here.
Oh.
Is anybody?
Everybody have their phone?
No.
Okay.
Thank
Thanks,
you.
though. That would be funny. Some dude was like, oh yeah, I was just in there. All right. Somebody right now, some guy in here is like, how am I going to get that phone back? All right. So now that we've set up where evidence starts, the next step, of course, is to see how much evidence do we find. So that's when we do our sample stuff. What do we know from our sample? What's X bar? Okay, and S is 15.6, and N is 37. So what's the new standard deviation going to be? Oh my God, Jeff. I know you can't write, but there. 16 2.67, 2.53. I don't know. What is it? I'm okay if I'm totally wrong. It's fine with me.
2.56.
What is it?
2.56.
I suck. 2.560? 2.564? Okay. All right. Is everybody with me? Please stop me if I'm not making sense. And now we can do what? Get our we got a rejection region t-score. Now I have to calculate my t-star to see where we fell. So our stuff minus what we think the middle's supposed to be, divided by the new standard deviation, and 25.2. It's like 1.9 something. No, 4. Holy crap, it's like 3 point something. I don't know. Somebody save me. I'm trying to. What is it? Okay. Okay, right? So what does that mean? Even if we didn't know any of this other shit, what would that by itself? Remembering that t-scores basically means the same thing as z-scores. 3.82 is pretty damn far away, pretty damn high, right? If 3.82 was your height score, you are tall as shit. You are tall. Sorry. I was going to say mother fruitcake. You're a tall person. Mother fruitcake. So if I look here, the test was actually going to be pretty difficult. 2.719 is pretty damn far away, but we blew that shit out the water. Right? So here's where H naught thinks everything is. Here's where our sample ended up. That is pretty good evidence that the one who thinks it's in here is wrong. So that's why right there we can say we reject the ho, support the high. So to be really honest, if your conclusion said we have found sufficient evidence to support the idea that the mean is not this, that is actually technically right, but your conclusion has to be in reference to the actual claim. So that's really all it is at the end. You say, what was the claim? I got to talk about the freaking claim, because that's what I'm testing. So which one was the claim? HO. So then what language do I use? That language. Because we're going to reject this claim. It doesn't look like it's equal to 290.6. It looks like it's higher in this case. So we have found Suf Ev to reject the claim. That plagiarize. What's it say the claim is? To reject the claim that the mean scores are the same for males and females. You can exactly just plagiarize what the claim is. So that's what I'm going to write down. Yes?
As a hypothetical, if the situation was reversed and the theory was that the scores are not the same, then we would invert the language and say we have not found sufficient evidence to support. To show evidence for H1, I have to get into the rejection region. So we made it. I'm not going to say we have not anything because we made it in. We succeeded. It's only if I don't make it in that I would ever say we have not found. So if the claim would have actually been this, the conclusion would have been we have found sufficient evidence to support the claim that the means are different. Because that's what the claim would have been then. Because that's the same thing. I just said the same thing twice. It's just that I have to say the one that references the claim. Right? I am not over 50 years old. I am under 50. I just said the same thing twice. I mean, so it's does it make sense? So if you make it in the rejection region, you succeeded. You succeeded. We have found evidence too. Then you want to use the correct language about the claim. Okay. So let me give you guys the answer key. I think some of you guys are just, and of course that one had to be on 3 sheets of paper, but or 3 sides anyway.
So you find out what's that corresponds to that. So you look at the area. Well, you know, a little bit.
All right. Ah. No. Ah.
Ten for me, that's the most. Yeah, you're right.
Make sure you end up with two sheets of key. I'm sorry, 2 sheets. I meant 3 sides when I said. Right. So if you look at number 9, guys, if you look at number 9, the original wording was different, and I didn't want to. I just, we just did it. So what the hell? There's your key. There's your key. All right. The way number 9 is worded on this key, it would be an extra credit. It would be 2 samples. Do you guys see that? I don't know if you can see through my scribble. It was originally actually 2 samples, and then I decided to make it a single one so there was more practice for what you're going to be really responsible for instead of bonus. Yeah.
The observed distribution on the key you gave us is also based on the
Oh shit. Core. Yeah, why not? Why not, Jeff? Damn it. So guys, apparently number 11 is different on the key and the test. I'm sorry. At some point, I don't know why I thought I'd make that change, and then I forgot to tell myself. Oh well, too bad. There was something else I wanted to say. Oh, let me nip this in the bud too. In the anyway, number 4, B2, the very last problem on the first page. Did somebody see the mistake I made? For the very last problem, 4B2. It sounds like a Star Wars droid. 4B2. Where are you? Cut the power to all the trash back. Yeah, no? Nobody can see? Yeah, I only went 1 step out. It should go 2. Okay. So I'm still averaging about a 97 on my inch piece. It's not bad. You guys see that? Right? Yes. Yes. So, guys, more people than you made the mistake. So, when you do a confidence interval, the conclusion, I know this sounds like just semantics, but it actually
needs to be this way to go along with the concept. In the conclusion to a confidence interval, we are blank percent confident that the interval blah 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 contains the true whatever. You can't say that. You can't say we are such and so confident that the true percentage falls in our interval, because that's not what happens. It's sitting somewhere existing. Our interval is what comes in. And maybe our interval catches it, or maybe our interval doesn't catch it. So if you say it the wrong way around, I know it sounds like I'm being real picky, why am I an English teacher all of a sudden, but the semantics actually changes the concept if you do it the wrong way. Ready? So you have to say, we are such and so confident that the interval we made actually catches the real whatever. You have to say it in that order. Yeah. So just to remind you guys, I think it's on the back of that lines sample that we did the other day. There's a kind of a checklist. This is sort of the way I would study back in the day. Of course, Jeff was such a geek. I was studying to the point where you'd say, all right, Jeff, calculate, you look over there, chapter 6, section 6.2, right? But you don't have to do that. But you should be able to go through and feel out how confident you are about the idea that's stated. And if you don't feel good about it, you go back and you write yourself some notes. So that one suggestion on how to do a test is to say, I want to try to do this kind of problem right now. You find that kind of problem, you do it. Because then you go into the problem knowing what it is. Instead of just coming, okay, now let's do number 2. Okay, what kind of problem is this? Oh, shit. So if you go, let me find this kind of problem, I'll get that done, great. And then I'll find this kind of problem, I'll get that done, great. That you don't have to do that. But that's not a bad idea, because it kind of reverses the whole, I go in knowing, instead of reading and going, the shit is this? Right? Maybe? So you don't have to be linear in your test-taking approach. You can do them out of order. That's fine. In fact, that's better.
Maybe I didn't check it, yeah.
Oh, guys, real quick. I'm actually going to be down here in the classroom tomorrow at 7:30. Yeah, just because. So, because I know a few of you guys still don't feel comfortable coming up there or whatever, so I'm going to be down here. I'll actually have snacks for myself. No, but you can have some. If you had me before for class, do the same thing. Bring in some cookies and some donut holes and yummy, yummy. Then I eat all the leftovers on the way out. It sucks, so please eat some of it. All right, that's it. Okay, buy it with all the change I just made.
Wake up, take a shower,